morning students, this is Junita Mukherjee once again with a new chapter of mechanical properties of solids for 11th standard physics. In this chapter we will learn something about the properties of the solids which are mechanical to us. Okay, so the solid in solids there are various properties related stress, strain and many more other things I will explain to you. So before starting this particular topic, let us see what are the different kinds of solids which we are using. Some are soft, some are really hard to touch. Okay, so we have some property such as elasticity of the particular object. Elasticity of a particular object make the particular object more hard, durable, and it will be easier to break it, and it will be much harder to break it, okay, into pieces. So elasticity is particularly a kind of a property in a particular object in which it can be bent or twisted into different shapes. That is what we call the elasticity. So the deformation of the elasticity is what we call the elasticity itself, or elastic deformation, and there is some tendency of regaining of its original shape when it is being twisted away with some pressure or something. That property is called is elasticity itself. Okay, so a particular object when being twisted out and it changed its particular shape after twisting of that particular shape itself, regain its original shape. That is what we call elasticity itself. And the property of deforming of the particular object into different shapes when certain kind of pressure is being given to that particular object is what we call the deforming elastic deformation. Okay, so now we will just discuss about this elastic behavior of solids. Some solids are much more elastic, such as rubber. In case of paper, it is not much elastic, means the solids, there is a property of elasticity in it also, but it is not just like the rubber, or just like the rubber band, or any other elastic things. So this particular property of the substances in which this spring ball mixed with model we can take. In this particular spring ball model, what we have ball and we have a spring itself, and whenever we will be able to twist that particular thing, it will regain its original position after some moment of time. So that particular thing is what we have, the elastic behavior of the solids itself, and this is how the ball is not being twisted up, but the spring is being twisted up, but it will change its particular position to a certain position, and that is what we call the elastic property itself of a solid. So some solids are there which regain its property, but some solids are there which are changed into elastic deformation. So that particular objects can be divided into two types. Okay, so that is I have explained to you already. So now stress and strain I am going to explain to you. The restoring force per unit area is called the stress itself. Now restoring force, the restoring force means the restoring force in equal in magnitude but opposite in direction to the applied force itself. And here the restoring force F the restoring force per unit area is known as the stress itself. If F is the force applied normal to the cross sectional area and A is the area of the cross section of the body, magnitude of the stress will be equal to F upon A. So the restoring force of an area per unit area is what we call stress itself. So magnitude of stress can be explained with the help of this particular fraction, that is 5F upon A itself. So the SI unit of this stress restoring force, or you can say stress, is what we have, Newton meter raised to -2 or Newton meter square or Pascal. Okay, so this is the unit SI unit of stress, and its well, the dimensional formula is m l raised to minus 2 t raised to minus l raised to minus 1 and t raised to minus 2. The change in the length, that is del L, to the original length of the body is known as the longitudinal strain. Now longitudinal strain is given by del L upon L, where del L is the original length of the body and L is the del is a change in the length of the body and L is the length of the body itself. So dividing these two values, we will get the longitudinal strain here. Now the strain so produced when there is a relative displacement of the faces del x to the length of the cylinder L. Now shearing strain is equal to del x upon L, that is equal to tan theta. Theta is the angular displacement of the cylinder itself. The strain so produced in the relative displacement, there is a relative displacement going on in the faces of the del x to the length of the cylinder L. So if the displacement is given by del x itself and L, so this two value, if we divide, this is what we call the shearing stress, that is defined by tan theta, and shearing strain is equal to tan theta is equal to theta itself. The strain produced by the hydraulic pressure is called the volume strain and is defined as the ratio of the change of the volume del V to the original volume V. That is, volume strain is equal to del V upon V. That is, del V is the change in the volume upon V, that is volume strain itself. So please go through this particular page number in detail. Some examples, through the examples it has been given in this particular chapter in page number 9.1, 9.2 and 9.3. Please read this particular things because time is no more and I have to give you more and more topics in between the things. So let me tell about the Hooke's law too. The Hooke's law. This particular Hooke's law is being defined by the stress and the strain of the different forms of the situations depicted in this particular chapter itself. So this is known as a Hooke's law, the small deformation of the strain and the stress in the proportion to each other. This is known as Hooke's law, and Hooke's law states that stress is directly proportional to strain itself. This is what we call the Hooke's law. That is, stress is directly proportional to strain, or you can directly write as stress is equal to K strain. Okay, so K is proportional to strain itself. So, into strain itself. So this is what we have, this particular value, that is stress is equals to strain, or stress is equals to K into strain. As we change this particular sign to equal to, there will be definitely a proportionality constant K, which is called the constant of proportionality, and modulus of and is called known as a modulus of elasticity. K is the modulus of elasticity here, and Hooke's law is an empirical law and is found to be valid for most particles, and these are some materials which do not exhibit the linear relationships. So we will be definitely going through the strain and stress curve. I will be explaining you the stress and strain curve in the detail in this chapter in the next video. Thank you so much.